And so next we're going to look at drawing two other triangles with slightly different specifications. So let's go ahead, look at problem 3, and let's draw. So A says draw a 2.5 inch segment with one endpoint at R. 2.5 inch, let me go ahead, get my my protractor. I'm going to use the ruler edge of it to measure off 2.5 inches, which is right over here. Okay. And one endpoint will be R, and this is my other point over here. At R, draw a 70-degree angle. So I go back to R, set up my protractor, center it properly, get everything all lined up, so everything is aligned. And let me draw a 70-degree angle. So I'm going to go to 70 degrees right there and draw a dot. And let me connect R to this dot. And then I've got a 70-degree angle. Very good. And on the other side of the 70-degree angle, draw a 3-inch segment. Okay, so I'm going to have to measure 3 inches off of this line here. So let me go ahead and take my straight edge here and let me measure 3 inches, which should be just about over here. Okay, so that is my triangle. Let me connect these two dots together, these 2 points, and there I've got my triangle. Okay, that's my first triangle. So again, this down here was 2.5 inches, this is 3 inches, and this is 70 degrees. Now, this is supposed to be B. Okay, so let's just change this to 3B. And I have to draw a 3-inch segment at the bottom. So let me measure 3 inches from R. And that would be about over here. Good. And again, I have to draw a 70-degree angle at R. So let me set this up perfectly aligned. I think everything looks good. 70 degrees. And I'm going to go ahead and I'm going to connect these 2 points like so. Okay, and I've got myself a nice 70 degrees here. This was from here to here 3 inches. And now on the other side of the 70-degree angle, draw a 2.5 inch segment. So I'm going to now measure off 2.5 inches from R, which gives me about this distance there. Okay, and that's going to be a vertex of the triangle there, and I can complete my triangle by connecting these 2 points, like so. Okay, so I've got my 2 triangles. I could, if I want, sort of either erase. I'm not sure how good this eraser is. I hope your eraser is better. This eraser is not going to do a good job, but we don't want to pay attention to that extra piece up there or that extra piece of line segment over here. Okay, so maybe I will just make sure that I know exactly what triangles we're looking at. Trace the first triangle on patty paper and compare it to the second triangle. Let's go ahead and do that. Let me trace the first triangle on patty paper. And you should follow along with me at home. Okay, good. And now for the third side. Okay, good. So I've got my first triangle traced. Remember, this is the triangle that had a 2.5 inch side, then a 70-degree angle, and then a 3-inch side. And now I'm going to take this patty paper and see, can I superimpose this triangle on this one? Well, let me figure out what directions can I go to superimpose it. Let me try that. No, that doesn't seem to work. Let me flip it all the way over to this side. Is that going to work? Yep, it does, right? Okay, that's probably just a little bit an error in the way I traced it, but that's close enough. That looks like a congruent triangle, right? It does fit right on top of the other one. So these two triangles are congruent. Well, why? Let's remember that this triangle had a 2.5 inch, 70 degree, and 3 inch dimension. And this was 3 inch, 70 degree, rather, and 2.5 inches. So they have a similar side, angle, and side. And what we can conclude is that triangle 1 is congruent to triangle 2 because of what we call side, angle, side. Okay, SAS, or side, angle, side. What this means is that a corresponding side, in this case these two sides that are 2.5 inches, an angle, which is the two 70-degree angles, and a second side, which is this 3-inch and this 3-inch side, are congruent. And if we have a side, angle, side between two triangles that are congruent, then we can conclude that the triangles themselves are congruent, or that one triangle can be placed right on top of the other. Okay, and we call 70 degrees in this scenario an included angle. And an included angle is basically an angle that is located between two sides. Okay, so in this case, 70 degrees is an included angle because it is between, sandwiched between the 2.5 inch and the 3-inch sides. Another way to say that is that the angle's sides are the two designated sides. Okay, and 70 degrees is also an included angle in the second triangle as well because it is between these two sides. So let's take a look and see what we've got on the bottom of the page. And we've got a typical statement for the side, angle, side congruence criteria. If we have two triangles here, ABC and triangle RST, and we're given that BC is congruent to ST, so that the length of BC equals the length of ST, and we can put little dash marks there, and also that the angle B is congruent or the same measure as the angle of S, we can put little double marks on those angles to show that those two angles are equal. And then finally, that side AB, let's put 3 lines through that, is congruent or equal measure with side RS. Then we have a side, an included angle, and a side in both of them. Side, included angle, and side. So our statement then is that triangle ABC is congruent to triangle RST. And the reason is because of side, angle, side. Side, angle, side. Corresponding side, angle, and side are congruent, and therefore the two triangles are themselves congruent.